just got these into the grade book, so you can keep these now. Yep. Okay. So, questions on this? Can you think of any reason that you would be gone tomorrow? I think a lot of the guys are possibly going down to Vermilion, but that may or may not include you ladies. Yes, no. To the best of your knowledge, are you here tomorrow? To the best of your knowledge, do you want to get this completed tomorrow?
Is the quiz tomorrow the one where we use our
flow charts? Yes. Or do you feel you need today and tomorrow? Yeah. Yes. You feel today and tomorrow will be beneficial for you. Okay. Well.
Is it going to be reactive?
Yes. That would be on Friday then, if I'm interpreting what you're saying correctly. You said today and tomorrow. Okay. Is that a general consensus, or is that just one? I see one nod, two nods, three nods. Okay. All right. So it doesn't mean we need to spend the entire hour on this with what was handed back to you, okay? Because some of those word problems do start like that. It'll say if you begin with this compound or you need to make this compound, how could you illustrate that? So one of the things that I would say that I've noticed is, remember, when you're using these common names, just go ahead and pick one. Aniline, toluene, benzoic acid, or phenol. Any one of them. Okay? So upon doing that, the moment that we call this okay, if we're going to use that common name of benzoic acid, what number of carbon is this one then? It's automatically the one carbon, okay? And that would be the same if this was toluene or a methyl group or an OH. That is automatically given number one because you're using that common name. So then what you could do is we could call this 3-chloro benzoic acid. Okay. You could also do meta-chloro benzoic acid, because that's one of the things I've noticed on your papers. There really isn't any consistency upon how you go about naming these, which there doesn't have to be. I mean, there's no one set right way to do these, okay? And then there would be one more you could possibly do, and that would be okay, and I've seen all three of these derivations on there, and that's fine. You just need to be able to pick one of these that you're more comfortable with. Okay, there's nothing wrong with this one. It just shortens it up a little bit, and with that, you can only do that if there's two derivatives on there. You got to remember that as well. Okay. And some of the papers, and it's just a simple mistake. These are really easy to fix. Okay. And now that we see that, we could probably say, oh, I can't believe I made that simple mistake. Okay. When we're looking at these two derivatives on here, okay, what's the difference between the two? They're both 3 carbon in nature. But the one on the left is a what group? left is a propyl group, and then this one is what? It's an isopropyl group. Okay. Simple mistakes, those can very easily be corrected. All right. Let's see here. And then I want to say, not everyone had done this, but this. Okay. Well, I guess I should probably write it how it was on there. Over there. Okay. Now, when you're doing these, again, remember, there's no one set perfect way of doing this. Probably using the common name is probably the simplest. Okay. And of all the common names we have, which one is this? It's toluene, and then once you call that toluene, okay, I'm going to run out of space here, but that's all right. Once we call that toluene, automatically which carbon is number 1? Okay, so this one is carbon number 1. All right, so with that, we can just put 1 there. Then we just need to go alphabetically and in the smallest possible combinations. And with that, we know that's a propyl group. This is an ethyl group. And of course, there we've got our chloral group. So alphabetically speaking, this one would be next. So with that, I'll just say that this one should come first after that one. And then, of course, this one, and then this one. So now we know which order they go in, but we just have to have the numbers. And then the lowest combination, would it be going clockwise or counterclockwise? Of course, with this one, once we get this assigned to number 2, okay, it's the second one we'd want to name because the chloral is going to come first, which this one's number 5 then, and of course this one here is number 4. And I don't mean to confuse. I think it's my intention that we can hopefully see that we want to go counterclockwise with this. So we've got 2-ethyl, then our, we want to do our chloral group first, which was 5-chloral. Okay, then the next one is our ethyl group, which is on the second one. And then our third one we want to name, which is on carbon number 4, propyltoluene. Okay, so nothing major. No one is really bombing out in this class. Okay, we're learning a few things. At least that is our goal. I mean, I can look at the grades that we've got assigned on here, and they're quite high, so it must mean we're learning something. At least, would you agree with that summation? We're learning a few things. Okay? So that's part of the naming aspect, okay? And I've just briefly looked at sounded like that came from. Does that mean we're done? We don't have a bomb going off here, do we? Maybe? Okay. So must have forgot we had that alarm going on. That go off right at 9? Yeah, computer's showing 9 o'clock. Okay. Okay, we don't even have to finish writing those unless you want, but which one of those two reactions will provide two products? And it's something that your flow chart would tell you. Bottom one gives two products. No, so it's actually, yeah, it would actually be the top one. Because remember, when there is something on this ring, okay, why is that important when you look at a halogen? Because it directs whatever it is you're adding to go into one spot or two. Actually, I should put metal catalyst on there. Okay. So we said that this one's going to give us two products. And we're not just making that up. How would we know that? One, I think we had told you that, okay? Not just now, but remember in that upper left-hand corner, besides that one reaction, doesn't it say something like alkyl groups, halogens, and it's got the letter X there. And on the very bottom, doesn't it say something about nitro group? Okay, so that's what I mean. That's something that we have gone over. And the top three, okay, and I think aniline was in here too. These top three will direct whatever it is you're adding on to in two spots. What are those? Ortho and para, which means this one all by its own is just that director, just a meta director. And the reason I think you probably knew that, you wrote that down on your chart, right? Right. Okay. Okay, so the last thing for today, we said we're going to get two products. Okay, so it breaks apart here because we've got this metal catalyst. So where would that methyl group go according to where this is? Just have, okay, so top or bottom? Okay, which by default then, just para, remember, is just straight across. Okay, so remember that is different than what we have here. This also splits apart. So where would the meta position be, and according to NO2, where it's at right now? Two away. Okay, so 1, 2, or 1, 2. So we'll just put them up here. There we go. Now the last thing that we'll throw into there tomorrow is, remember, if we have an alkyl group, you got to pay attention. Is it heat or a metal catalyst? But we'll cross that bridge tomorrow. Okay, catch up to you next time.